Today we solve a numerical question with the help of randomized complete block design. But if you are new on my channel Statisticians Club, please subscribe the channel. Here is the statement of question. 4 varieties of wheat were tried in a randomized complete block design in 4 applications. Yield in kilogram per plot is shown in table. Test the hypothesis that there is no difference in the mean of 4 varieties. Here is the data. These are the replications. In other words, we can say it as blocks. And here is the varieties. These are the treatments V1, V2, V3 and V4. And each block is replicated 4 times. As you can see, each treatment is also repeated 4 times. And because in this question we introduced blocking, so this is the question of randomized complete block design. Now we solve this. The statistical model for randomized complete block design or RCB design, which is its abbreviation, is Yj is equal to mu plus Bi plus Tj plus Eij. Yj is the observation corresponding to block I, where I varies from 1 to so on R, and treatment J, and J varies from 1 to so on K. Mu is overall mean effect, Bi is block effect, Ti is treatment effect, and Eij is random error, which is normally distributed with mean 0 and variance sigma square. First step is formulate hypothesis. H0, which is our null hypothesis, Tj is equal to 0, J is equal to 1, 2, so on 4, because we have 4 treatments V1, V2, V3 and V4. So in other words, we can say this as there is no difference in the means of 4 varieties of wheat. H1 Tj not equal to 0. Not all 4 means are equal. As you know, alternative hypothesis is opposite from the null hypothesis, and alternative hypothesis assume that treatment means are not equal. Not equal sign used in alternative hypothesis and equal sign used in null hypothesis. Second step is level of significance. We choose significance level. Traditionally we use 0.05 as level of significance, so we use 0.05 here. Test statistics. Test statistics to be used. F test is used. ST square mean square error for treatment and SE square mean square for error. Under H0 it follows F distribution with degree of freedom k-1 and V2 k-1 and R-1, which is also called the error degree of freedom. Next step is computation. This is our data set. For Yij square, we required square of each term and then summing. So square each term here. 2 square 4, 2 square 4, 4 square 16. Similarly so on, 3 square 9. So squaring every term. Adding this term row side, 2 plus 5 7 plus 4 9, 2 plus 5 7 plus 4 11 plus 1 12. So first is 12, second 2 plus 3 5, 3 8 1 9. So adding row wise, we got Bi dot. Bi dot means B1 dot, this is B2 dot, this is first block, and dot means there are variation in values on column side. As you know, this is first column, this is second, so we say this as bi dot. Similarly, adding this term, 1 plus 4 5 plus 2 7 plus 3 10, bi dot square, squaring this 12 square 144, 9 square and 18 square, 10 square 100, and here is the sum of bi dot square 649, sum of bi dot 49. Here adding the square term, because we here yi dot square, e term square, 4 plus 25 29, 29 plus 16 45 plus 1 46. Similarly, summing these square terms, we got yij square, so this is 191. On column side, t dot j, so j is on column side we assume variation as j, and dot means because there is number of rows, so we assume dot. This is the t dot 1. Adding these terms, 2 plus 2 plus 4 plus 1 9, t dot 2 6 plus 4 10 plus 8 18, and similarly t dot 4, t dot j square, 9 square 81, 18 square 3 to 4, 15 square 7 square 49, yij square, 25 86 65 15, here is the sum 191, and y bar dot j, by dividing this term to the number of observations, 9 divided by 4 2.25 y bar dot j, and similarly continue the same procedure, 7 divided by 4 1.75. so now we moves towards our formulas. Correction factor is obtained by grand total square over n. So squaring 49 square divided by 16, we obtain correction factor which is 150.06. And next is total sum of square, which is abbreviated by TSS, double sum yij square. These two summation shows one is variation on row sides and this is variation on column side, minus g square over n. TSS yij square 191. Here we calculate 191 yij square minus correction factor. Our total sum of square is 40.94. Treatment sum of square. Sum of j t dot j square over r minus correction factor which is g square over rk. N is equal to rk. R means number of replication, k means number of treatment. We have in our question 4 application and 4 treatments. 4 multiply 4 16, so our n is 16. So summation t dot j square, this is summation t dot j square, these are the t dot 1 square, summing all these all 4 terms, we got the answer 679. So 679 divided by 4 minus correction factor, there is here is treatment sum of square 19.69. Block sum of square, other name of block sum of square is replication sum of square. Sum of I bi dot square over k minus correction factor. Bi dot square 649. This is bi dot square, sum of bi dot square 649 divided by 4 minus correction factor. So after simplification, replication SS is equal to 12.19. The sum of square for experimental error is obtained by subtraction from total sum of square minus treatment sum of square minus replication sum of square. So we can obtain error sum of square by using this formula. Analysis of variance or ANOVA table is represented as, here is the source of variation. Our source of variation first is treatment. Because this is randomized complete block design, so the second source of variation is replication, or other name is block, and then error, and finally we total. First we check treatment degree of freedom. We represent treatment by k, so treatment degree of freedom is k minus 1. We have 4 treatment, 4 minus 1 is equal to 3, so here is 3. Treatment sum of square as we calculated above, 19.69. so 19.69. mean square for treatment is obtained by sum of square for treatment divided by its degree of freedom. So 19.69 divided by 3, we got answer mean square error for treatment. Replication sum of square, r minus 1, 4 minus 1, 3. So here is the replication sum of square, 12.19. 12.19 divided by 3, mean square error, mean square 4.06. Here is total, rk minus 1. Total number of observations are 16 minus 1, 15. So the total sum of square is 40.94. And error sum of square is obtained total sum of square minus treatment sum of square, replication sum of square. We got the answer 9.06. Similarly, we obtain its degree of freedom, error 15 minus replication 3 minus treatment 3, 15 minus 6, 9. But we have the formula of error. Here is k minus 1 and r minus 1. K 1, 2, 3, 4. 4 treatments. 4 minus 1, 3. Replication 1, 2, 3, 4. 4 minus 1, 3. 3 multiplied by 3, 9. So k minus 1 and r minus 1 is also the formula of error degree of freedom. So you can obtain the error degree of freedom from its formula, or simply subtracting treatment and replication degree of freedom from the total degree of freedom. So after we obtain error sum of square, mean square for error is 9.06 divided by its degree of freedom 9, we got this answer 1.01. F computed value, this is the computed value for treatment and this is for replication. But our question is about treatment. We check that treatments are equal or not, so we deal only with this observation. Critical region f greater than f.05 v1 3, this is error degree of freedom for treatment, which is k minus 1, and for error 9. So we check it in f table, v1 3 and v2 9. Our table value is 3.86. Because our computed value 6.50 is greater than 3.86, so we reject h0 and accept h1, and concluded that means of our 4 varieties of wheat are significantly different. So here is the conclusion that I write: the computed value f6.50 is greater than the table value 3.86. So computed value f1 falls in critical region. So we reject our null hypothesis and concluded that means of our all 4 varieties of wheat are significantly different. So since the F test indicates rejection of the null hypothesis, we apply LSD test, least significant difference test, to find out which mean differs significantly. LSD is equal to T alpha by 2, error degree of freedom under root 2 SC square over R. T alpha by 2 0.025, error degree of freedom 9, under 2 multiplied by standard error, this is error sum of square 1.01, and divided by its replication 4. So after simplification we have the LSD value 1.60. Arrange the mean of the 4 varieties of wheat in ascending order of magnitude. So the mean of 4 varieties that we calculated in this table. Here is the mean. We arrange these means in ascending order. This is V4, I think this is first, and then this V1 and V3 and V2. So we arrange in ascending order V4, V1, V3, V2. So their difference 1.50, 2.25 is less than 1.60. Similarly, V1 and V3 is less. So these are so these treatments that are underlined, their difference is insignificant, and remaining combinations have significantly different. So we check this with the help of LSD test. So arrange the mean of 4 varieties of wheat in ascending order of magnitude and draw a line under the any subsets of adjacent means that do not differ significantly. So these are insignificant. In other words, we can say that these pairs do not differ significantly, and remaining pairs like V4 with V3, they are significantly different. So if you want to watch videos of randomized complete block design, advantages and disadvantages of randomized complete block design, layout of randomized complete block design, then please click the link in front of your screen. Thanks for watching.